Good morning, everyone. Welcome again in the last class or in the fifth class of the CNC. This is we'll take some examples in this class. So initially we will take some simple job of milling operations. Okay, this is the program notes. Program in the absolute mode. We have already told you that if something is already written in the questions paper, you have to take only that mode. Otherwise, you can take at your own. Okay, so the this is some information purpose. The aluminium is important. uh, why this type of information is given in the question paper? Because on the depending on the what kind of material you machine, this is dependent on the feed rate. So if the machine is type of aluminium or ductile material or soft material, then feed rate high. Or if instead of aluminum it is steel, then feed rate should be less. So this is the main thing. That's why this type of information is given. The cutting tool is the 10 millimeter diameter high speed steel, that is HSS, high speed steel, 2 fluid end mill. This is the information purpose. Again, 10 millimeter diameter means you have to mention somewhere which is 10 millimeter. And after the job is completed, return to the tool change position, or this is the home positions actually. So this is the home positions already mentioned in the questions paper, because this with the informations, this type of figure is also provided in the questions paper. Okay, so how you will do that? So initially, the home from the home positions, with you have to take the uh, tool from to the A position, because it is your 00 position. So what is the program? So initially we have to take the sequence number, then some G90 absolute mode of programming, because your questions paper already given that you have to program in the absolute mode of programming. Absolute mode of programming means all the coordinate points will be calculated from the 00 point only. G21 means it is in the millimeter. In the all the units that we have not mentioned, as like the drawing. You all know, when you have drawn something, then this anywhere the dimension is not given in the drawing. It is somewhere in the above the title box or within the title box. You have mentioned that all dimensions are in millimeter. Like that, here also you have to mention it either G21 or G20. Okay, if it is inch, the dimension are inch, then it is 20 or 70. G21 is the for the millimeter, or G71. Some books is also written 71 also, but you will remember only 20 and 21. 20 is the for inch, 21 for the millimeter. Now N10, you have seen that N5, after N5 we will give N10, because we want to give some gap in between 5 and 10, because if we want to incorporate after all the programs done, then we can incorporate here with the sequence number of N6 or the N7 or N8 or N9, like that. That's why we will give some gap, but it is not so important. You can give at your own. Okay, it is not so important, and it will be not counted by the tool also, because it is not a direct programming, but it will be understood by the MCU. If any kind of error will there, it will shows you that in the sequence number 10 the error is there. So that's why it is also important also. So T1 is the tool. This is the thing. M6 is the tool change, and T1 is the number of tool where it is already situated. Then N15 sequence number G92. This is absolute zero shift that I have already told you in the when I have discussed about the programming, different programming codes. G92 is the absolute zero shift. So this is the home position. So this is the coordinate point minus 100, 86, 95. So this is you have to mention with the G92. That is the absolute zero shift. What does it mean? Absolute zero means after machining operation, it will go to the absolute zero shift position. G92, X minus 100, Y 86, Z 95. This is nothing but the coordinate point of this position. Now G20, G20, N and 20 is the sequence number. G28 is the machine zero, workpiece 0 point on where you start the machining operation. So this after that you have to give X0, Y0, because it's a milling operation. So z is not important here because in the surface actually you are cutting this because already tool is here, and you just face the this kind type of facing you are making. So that's why z is not so important. X and y movement is important here because already your tool in the certain depth of the from the workpiece. Now M03 and S in this spindle start and with the 2500 RPM. So this is the things you have to mention. After that N25 Z 12.5. Now what is the meaning of Z 12.5? Initially it is above from the J2 positive 12.5. What does it mean? That means if it's a 00 positions from the 00 to 12.5 above 12.5 millimeter Z is there. Okay, so for the safest positions it will after that when I will want to make operation it needs to be downward, then look like that. N30, then G1. G1 is the what is the G1 code meaning? This is a linear interpolations. Okay, now Z 12.5. Initially my tool was if this is the surface of the workpiece, from the surface of the workpiece it was above 12.5 mm. If I want to make some this type of shape or want to cut, so that means we have to give that again negative minus 12.5. That means it will just touch the workpiece. Then if G1 is the comment, then you have to give some F also. This is the feed rate, millimeter per minute. Then M08 for the coolant on. You have to on the coolant because machining will start its operations. Then N35 is a sequence number, X20 minus 20, Y30. Okay, so this is your now 00 position. So everything's the tool has already moved to its minus 12 point and it just touches. Now it will cut. Okay, so now from A position to B position, you want to move the tool with some code. So what will be the code? Code will be X minus 20 and Y 30. Why linear interpolation? I have not provided G01. I have not provided because it has already provided in the last part. When I will change the type of interpolation, then only I have to mention from G1 to the G2 or G3 like that. But if I will not mention, it will take from the previous one. That's why here I will not mention the linear interpolation with the feed rate because I want to move the tool with same linear interpolation G1 and with same feed rate 150 millimeter per minute. So that is the case. Then I am just moving the tool from A to B, and you if you see that it is minus X direction and it is positive Y direction. That's why minus 20 plus 30. Now from B to C I want to move, and for that reason I have to change my interpolation from linear to the circular because this is the circular path. From B to C, now I have to change the absolute mode of programming I am doing. So I have to take all the coordinate from the from this 00 form. This is the 00 point. From the 00 position I have to calculate the coordinate point of C. What is the coordinate point of C here? This is plus 10, it is x-axis, and from the y it is how much? 30 and 70. So this is 30 and this is 70. So in y it is positive 100 and x it is positive 10. And what is the radius of the curvature? This is 80. Okay, so what I will mention, then sequence number, then G2 is the circular interpolation clockwise. If this type of curvature will there, then I will mention G03 because it's a counterclockwise. Now this type of curvature G02, then X10, I have already told X10 and Y20. This is the coordinate point at C point, coordinate point of C point from the 00 point because it is just 10 point from the 00 X, and 30 and 70 is the 100 from the Y, and radius you have to mention this is R80. So I will move the tool with the same feed rate. That's why I have not mentioned the feed rate like this 150 because it will take from its previous point. If I will change the feed, then I have to mention the feed. Here I will not mention, though this is important. So now next part will be the from C to D point. It will again uh, go into the linear position. That's why I need to mention the G1 also. Now I have to mention the coordinate point of D. What is the coordinate point of D? So it is from the 0 0, it is 150 minus 10, because it is somewhere behind the 150. And how much behind? 10 millimeter behind. So 150 minus 10 is the 140 x coordinate, and it is how much? The distance is 60. That's why you have to mention y60. So now it will come to the D position. Now D to E position, again counterclockwise movement will be there, so you have to mention sorry, it is again clockwise movement, so you have to mention G2. Then coordinate point of E you have to mention. So from this, if this is 0 0 point, so this is directly 150 and it is on the x-axis, so y coordinate will be 0. And R50, this is the radius of that curvature that I have already mentioned. So now G1, so you have to come to this E point to the A point again, otherwise this face will not cut. So for that reason, I will again move to this x0 y0. And now all the machining operation has been done. So I want to move the tool to its safest position, which I have mentioned 12.5. So it is actually dependent on you where you want to take its tool after its machining operation. So for my case, I have mentioned is 12.5. You can take its 2 or 5. So minimum 5 millimeter is needed. So you it is up to you. Okay. So 12.5. So I have mentioned G0. Why? Because I am moving the tool to the safest place. So here no material is there. We are moving at the Z positive. So I can move the tool to its highest velocity or highest speed. So that's why I have mentioned G0. That is nothing but the rapid traverse. So rapid traverse, when I will want to move the tool to its maximum velocity, then the rapid traverse is used. So G0 is the rapid traverse. Then J12.5 means it will go into the safest place. Now I again G28, I will mention the machine reference point x0 y0 as per the previous one, M5. Then I will stop the spindle, then I will end the program. Okay, so this is the end of the my milling operation. Now I will go into the one turning operation. So here also same things, it is important. Already given some informations, and here important information is the depth of cut 0.5 millimeter per pass. So if I want to take the 0.5 millimeter per pass, then it in diameter it will take 1 millimeter. The coordinate change will be the 1 millimeter in the x direction. Okay, so this is your x and this is your z. So this is your positive x, this is your positive z, so this is your negative z, like that. So what is our main purpose? Our purpose is to reduce the diameter from initially it is 22 and length is 60. Our purpose is to from the 22 millimeter up to a certain length, that is 30 millimeter, we want to reduce the diameter in a turning operation by 14 millimeter. Okay, how we will do that? So this is the sequence number part program, and this is the billet size you can write. Now previously we have already shown this is 21 is the millimeter per minute, G90 it is the feet per minute option. So G28 U0 W0 you have mentioned that 0 U0 W0 is the machine reference point or workpiece reference point somewhere here. And now I will take the tool change option. So tool change, or you have to mention the turning tool is there G03, and at that number 3, this is the things. And now M03 option, this is the spindle speed at 1200 rpm it will start. M03 is a spindle start. Now G00 X22 Z1. So what does it mean? So this is a 1 millimeter, this is your x and this is your z. So positive z, this is your z, positive z. So positive z means, so from the workpiece, if this is 00, so from the workpiece it is away from the workpiece with 1 millimeter. Okay, and x22 is the coordinate point of 22. So initially this is your billet. So initially blank portion. Okay, so somewhere here is your uh, turning tool. So this is positive z, and this is your positive x. Okay, here I have machine, I have considered my machine is here. So away from the motor, motor is somewhere here. So away from the motor is positive, this is positive, positive x, sorry, this is positive x. And away from the motor, my motor is here for the turning, and away from the motor this is positive z. So if this is mentioned x22 z1, that means x22 means here somewhere here x22, and this is 1 millimeter away from the upper surface of the workpiece. So now I will move z20 x21 z minus 30. So z negative, this side is negative, so my turning operation will be like that. So 1 millimeter, I have given 0.5 millimeter depth of cut. So 1 millimeter per pass, it will remove the material. So accordingly, I need to change my coordinate point. So only for the turning, I need to mention only the coordinate point, nothing more than that. So x21, this is the change my coordinate point from 22, it is 21. Now z minus 30, because I want to reduce the diameter only the length of 30 mm, not up to the 60 mm. I am only taking the length only 30 mm. So this is minus 30 because I have taken this as my positive z. So this should be minus 30, and feed z I have given 45. Now again, after this operation, again tool will move to its initial position, that is above surface 1 millimeter, 22, and z1 means from the upper surface it is 1 millimeter away, or the outer surface 1 millimeter from the outer surface. So now g01 again, it will be from 21 to 20. Again same thing, then we will return to its actual positions. Then again 20 to 19, like that we have to mention this up to 14. Okay, so after the 14 again it will come to its original position. Then we some certain things we have to mention, that is machine 0 point u0 w0. So here turning, actually u is nothing but x and w is nothing but z. X and z is considered as u and w. Okay, it is only the case for turning. Otherwise, all the axis is written x, y, and z. For only the turning, u and w is specified, and u sometimes v is, if y axis is not there. Okay, so that's why u and w is mentioned. So u v w actually, so v y is not there for the turning or the lathe. So that's why u and w is important here. So now the spindle stop, program end, and so school end off, and program end. So these are the codes you may use. So now this is the drilling operation. Another thing is the drilling operation. So in the drilling operation, I will show you how the cant circle will be used, and will with another example, that how the general drilling operation can be written. So this is the actually reference plane or clearance plane, you can say. So this is the here already dimension is mentioned. So this is the three positions where I want to make my drill. So this is the positions. This is the initial position A. Then B, C, and D portion I want to make some hole with some certain distance, and thickness of the workpiece is 15 mm. Okay, so reference plane is 2 millimeter. 2 millimeter away. So this is 2 millimeter clearance plane. I want to make the tool that it will not contact or physical contact so with the workpiece, otherwise the tool workpiece will may damage. So that's why may give the clearance plane, which is above 2 millimeter from the above surface of the workpiece. So now the coordinate point has already been given. 25 35 is the first coordinate point, that is v point. 55 50 is the second coordinate point, and as d point 70 and 75 is the coordinate point, and total billet is the size of 100. and the depth of the workpiece is the 15 mm. So according to it, and reference plane, this dotted line is nothing but reference plane, clearance plane. So on the basis of that, I have to give some uh, code. So how we will do that? So this is the code for the general one, and this is the code for the canned circle. What is this is the sequence number. G00 is the rapid traverse, X25 Y35 Z2. So X25 Y35 is the coordinate point of B. Okay, from the 00 point to the B point, I will just coordinate. I have mentioned the coordinate point of V, that is 25 35, and Z2. So what does it mean Z2? I am just keeping my tool above 2 millimeter from the above surface of the tool, because this is my, I have chosen the clearance plane away from the above surface of the tool. It's a 2 millimeter. So this is my case, Z2. Now I will start my drilling operation. G1 will be there because linear interpolation. Now I want to move my tool with my desired feed rate, that is 125 millimeter per minute, minus 18. Why I will give minus 18 depth of cut? Because just look, the depth of cut 15, 15 is the thickness of the job. So 15 is needed to through hole drilling, because I want to make through hole. 15 is needed. Now my current position of the tool is away above from the 2 millimeter. So 15 plus 2 is a 17. Then I want to make my tool to 1 millimeter extra, because I want to, otherwise what will happen, the bottom portion, some excess material will remain there. So I want to make through hole, that's why I will give 1 millimeter extra. So that's why I given my z direction negative 18 millimeter. So 15 millimeter is my depth of the workpiece, or the thickness of the workpiece. 2 millimeter is my now current position from away from the tool. So this would be mentioned, or this should be taken. 15 plus 2 is 17. Now I want to make my drill to below 1 millimeter from the lower portion of the workpiece. That's why I given 18 millimeter. Okay, and with certain desired feed rate, that is 125 millimeter. Now sequence number G00 and Z2. So every time, so after drilling operations, I will again move to my initial position where I have started. It's a reference plane or a gauge height or clearance plane Z2. So at this case, I can move my tool to its highest velocity, that is rapid traverse G00. So now again I will move my tool to the third position. Sorry, third positions. That is this 55 and 50. This is the position of C, 55 and 50. Then again same types of things will be repeated, because here all the drilling I will make the same plane, from the same height to the same thickness I will make. That's why the same type of repetitions I can make. So if this is the case, so 55 50, then again the same things I will make. Then I will again retract the tool. Then 75 70 is the my third number, that is D, coordinate point. 75, this 75 and 70. Okay, so 75 70 is the my third locations of the drilling. And then we will again mention minus 18 if 125. Now drilling operation is going on. I have given GG1 linear interpolation. Then again I will retract the tool to its actual position. Then I will again retract the tool to its safest place, that is Z50, away from the 50 millimeter. So if this is the case, only the coordinate point is already changing. Other thing, that is my depth of the drilling, is not changing. In that case, we can use can cycle. So where I can use can cycle, where the depth of the drilling is same, only I am changing the different location. Okay, so and in that case we can shorten the program number. So there is the total length of the program for the three different location drilling. Now the same work I can do with the can cycle. What does it mean, can cycle? So this is the reference number G81. Recall that I have already mentioned some G81 is the can cycle used for the drilling purpose. Okay, can cycle. So there are different can cycle coding. for counter boring, these are the milling operation also. So these are the 81 is the can cycle for drilling operation. Now I will mention the coordinate point x25 y35. Now it is the initial position where I want to make my tool. This is the first coordinate point 25 35 b position. Okay, z minus 18 I have consider here. From the my current location, tool will move z minus 18 because I want to move through hole. Okay, and R2 here you have to mention. If you want to make the can cycle G81, then next step you have to mention the current location of the tool from where you want to start. Then the Z you have to specify once, because every times you need not to specify, because it is can cycle, it will be repeating manner. So after the first line you will only mention the coordinate point, the others. So this is, that's why you have to mention once what will be your z coordinate point. And after that r2 is nothing but after doing the operation. You can see over here that after the drilling operation it will go to its reference plane, that is above the above surface of the 2 millimeter above surface of the workpiece, that is z02, and this is nothing but the reference plane. So after that the reference plane will be there, the retract the tool after the drilling operation, retract the tool to its 2 millimeter above surface of the workpiece. Then f125 is the feed rate. So initially you will mention that. Then next line you will mention just second coordinate point x55 y50, that is the coordinate point my C point 55 and 50, and third coordinate point 75 and 70 I will mention in the third line. So 75 and 70, because after every drilling operation it will go to its actual place, that is R2. So this is the case. So now this is the actually G20 X0 Y0 Z50 is the, I want to make the my tool to its above 50 millimeter from the surface of the workpiece to its safest place. So you can see that with this number of lines you can reduce with the can cycle with the only three numbers. Of only these three numbers is important for your drilling. In the first line you have mentioned all the things, second line you just, if this type of drilling operation you can also mention another five or six position. Here also you have to just specify these five or six positions, nothing more than that. And I have already told you it is only applicable where the every time you are making the depth of the hole is same. Okay, so otherwise can cycle is not be taken. So this is the applications and importance of can cycle. With this I will conclude my sessions here. Thank you for your patience here.